So all the people who are asking for previous class recorded videos, please go to 360digitmg.com. Please go to 360digitmg.com. Are you all there on the website? Everyone, please do that. Please go on 360digitmg.com. Yeah. If you all are here, then just scroll down completely. After you scroll down completely, you will see follow us options. In that, do you see YouTube? Do you see the YouTube link there? Please click on this. I request everyone to please click on this. Once you click on this, you will be landing on our YouTube channel. Do not forget to subscribe first thing. And here is a video. Okay, here is a video. And all the video links would be available here. You might want to watch. Okay, here, subscribe to our channel and then you'll have this. Is that clear, friends? So I'm assuming that this doubt is clear. Okay. And also there is another link, sticky note. Should we put it there, Enoch? Do we need to put a sticky message? On the chat window on the top, you'll have something called as sticky message. On that sticky message, we are going to put the YouTube channel link and you can find the videos over there. Okay. Enoch, please, can you do that? Yep. Guys, on the chat window on the top, you would see a link. Please click on that. Okay, please click on that. All right, please click on that and then done. All right, now let's move on to the lucky draw. Everyone is waiting. There is a lot of, there are a lot of people who are asking to first run this. Okay, so yesterday we have found that these many people have given the attendance. We already shared the attendance form. We already posted on the chat window. We have put it on the sticky window. That is on top of your chat box, you would see a sticky message in yellow color, pale yellow. It's listed there. Okay. It will also be listed today towards the end of the session, and you'll have to give your attendance. So we have 1,182 people in total. So what I will do is I would go to Google, random number generator, 1 to 1,182, right? We have, I repeat, 1,182 people. So I put those numbers there. I'm testing now. I'm testing it. I'm not running actually, okay? I will just test and show you on whether it is right or wrong. See, randomly numbers are getting generated when I click on generate, okay? So now I will click on generate and you guys will be able to see on who has won the lucky coupon from Amazon. Who is that lucky person? Let's see. 1, 2, 3, go. Okay, 675. Let's see who that lucky person is. 675. 675. There we go. Do we have Karthik Raja N? Do we have Karthik Raja N? He is the person who has won. He is the person who has won today. Okay, Karthik Raja N. Karthik Raja, are you there? Who told Abhishek? Single digit is never generated, it seems. Who told you? Abhishek? Are you even aware of how this works? Randomly, it chooses from this range. Randomly. You keep generating, sit on it. every number being chosen is equally likely. Okay, for the entire day sit and do this, you'll come to know. Don't spread rumors, guys. Be educated, okay? Don't spread rumors. Very bad. All right, let's continue now. Okay, I'll give this link to one of my friend. Okay, guys, you're seeing, right? Who is that person? Okay, just go, just go to Google, type random number generator and keep typing, man. Someone was telling this. 51. Do you see that? Do you see that? Okay. Do you see that? My dear friend, do you see that? People who are raising this. Very bad on your part. You all are students, right? So you all should be good students. Do you see that? All right. So random number generator is something which would randomly generate. Okay, let's move on now. So let us do a quick recap and then let us proceed further. The first step in any data science project is to understand what is the business problem that we try to solve. Tomorrow, when you join any organization, any company, you might join TCS, or you might join CTS, or you might join Wipro, or you might join Deloitte, you might join any company. Okay, you might join any company whatsoever. The moment you join these organizations as data analytics professionals, when you join as data analytics professionals, the first and foremost step is to understand the business problem. That's the first step. First, try to understand the business problem. Once you understand the business problem, then you have to proceed to the next step, which is data collection. Data collection. Once you collect the data, this is exactly what you do. And this is exactly how you do when you join any company in the future. When you join any company in the future, this is exactly what you do. So you have the business problem, then you collect the data. Once you collect the data, you perform analysis of the data, which is called as exploratory data analysis. You proceed with exploratory data analysis. You explore the data. You try to identify meaningful insights from the data. Okay. As part of data collection, you need to understand about various data types. And what are the data types that we have understood yesterday? Day before yesterday? Continuous data and discrete data. Any data which can be represented in a decimal format. Any data which can be represented in a decimal format, and if it makes sense, that is continuous data. Any data which you represent in decimal format, and if it does not make sense, that is discrete data. And then you have various other data types such as nominal data, ordinal data, interval data, and ratio data. We have all these various data types. Once you have the data, you need to perform exploratory data analysis. As part of exploratory data analysis, we discussed about first moment business decision, which is also called as measures of central tendency. There are three measures of central tendency. You have mean, median, and mode. You have mean, median, and mode. You also have second moment business decision, measures of dispersion. There are three measures of dispersion: variance, standard deviation, and range. There are variance, standard deviation, and range. Three measures of dispersion. We have discussed all of these in the previous session. Then we got introduced to R. And then we have also calculated mean, median, variance, standard deviation, and range using R. Then we also have graphical representation. As part of graphical representation, we have looked at bar plot, then we looked at histogram, then we looked at box plot. Bar plot is just going to give you bars, nothing much that you can glean from the bar plot. When it comes to histogram, it is also called as frequency plot. It is mainly used to identify the shape of the data distribution. How is the data distributed? How is the shape? And box plot is used to identify outliers. This is what we have discussed. And we have also resorted to R, and then we have solved a few of these things. Okay. Now let us move on and understand a few more things about graphical representation. All these three are called as univariate plots. Bar plot, histogram, box plot. These are all univariate plots. Then you have bivariate plots. Bivariate means when you want to analyze two variables. When you want to analyze two variables, then you use bivariate. Univariate is used when you want to analyze a single variable. All these are used to analyze single variable. When you want to analyze two variables, it is bivariate. Within this bivariate, today we are going to discuss about a plot called as scatter plot. We're going to discuss about something called as scatter plot. Scatter plot is used to identify three things. I'll explain that in detail. What are those three things? Number one, it will help you identify the direction. What does that mean? We will learn in a moment from now. Next, it will help you identify the strength. Third, it will help you identify whether the relationship is linear or non-linear. Now we will do this. We will get into this and then we will learn about first scatter plot. Even before we proceed further, the one thing that you guys should be aware of is this equation. Y is equal to f of x. any output, any output that you want to achieve is equivalent to inputs. For example, say you want to identify the weight gain, amount of weight that you're going to gain. It depends on maybe an input called calories consumed. Calories consumed. Weight gain is an output which depends on calories consumed. Or maybe output could be, will I get a job or not? Will I get a job or not? It depends on what? Multiple inputs. One input obviously would be your attendance in your colleges, whether you're attending all the classes or not in your college, or whether you're attending all the sessions or not, training sessions in that way. Next, what is the amount of effort that you spend on assignments or homework? Third, do you know what, in final year, there is an internship that you do. You go to organizations and do a project. A few of them opt for some kind of a project which is already done by someone else. A few of them who have the interest actually do it, right? So that live project is very, very important, friends. It is very important. On your profile, when you put that, people will ask you questions around that live project. Okay. So whether you'll get a job or not depends on your attendance. It depends on your assignment. It depends on your live project and many other things like your attitude and all that. The point that I'm trying to drive is any output that you want to achieve, it depends on either a single input or multiple inputs. Okay, this equation should be very clear because today we are going to build our first machine learning algorithm. First prediction model is what we'll build. Okay, before that, let's understand this. So guys, this is how it works in real world. Customer will tell you what problem they are facing. You would collect the data and you'll first explore the data. You perform exploratory data analysis. And in a Word document, you calculate the first moment business decision, second moment business decision, graphical representations, and after each point, you write down your business inferences. After each point, you write down your business inferences. First thing is univariate plot, then bivariate. Now we are discussing bivariate. Here, scatter plot is all about establishing the relationship between two variables. Say you have one variable here and another variable here. When you look at the correlation, if you see that it's increasing, then it is called as positive. So let me explain it better by taking some example. Okay. A few years back, I mean, working professionals might not like it, but this is what was published on workforce analytics. Workforce analytics. What do you mean by workforce analytics? I mean, humans who work. That's workforce. Doing some analytics on that. Then people thought, okay, let us do one thing. Um, and okay, let me take a rather simple example for you all first, and then I'll go to workforce analytics. X. Say on x-axis, you plot the time spent in a shopping mall. I understand that all the shopping malls are closed now. Time spent in shopping mall, how much time you spend. And say you're doing this analysis because a shopping mall owner say came to you saying that the number of people who visit my shopping mall versus the amount of money that they spend is not in proportion. He might say, hey, can you help my shopping mall become profitable? Because you are now learning data science. Say they ask you this, that, hey, can you help me become profitable? Then say you thought for a while and then you decided that let me look at this analysis on how much time people spend in shopping mall versus how much amount they spend, money spent. Okay, money spent. So here you have 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7 hours. Say you this is the amount of time that you spend, and money spent, maybe you'll spend 100 rupees, 500, right? Maybe 1,000, maybe 1,500, so on and so forth. Say you are a bachelor, you went to a shopping mall. For 1 hour time that you spent, say you spent 100 rupees. Then you spent another hour, 2 hours in total. Say you spent 500 rupees. For the third hour, you were doing, say, window shopping. You did not purchase anything. For the fourth hour, you were just sitting there and relaxing and checking out people who are entering and leaving. For fifth hour, sixth hour, seventh hour, you just were spending. Summer season, so let me relax myself in AC. Probably that's what you would have done. Now, if you see such a correlation where as and how the time spent in shopping mall increases, if the money spent does not increase, if it remains constant, then that means there is no correlation. There is no correlation between money spent and time spent. But assume that you entered the shopping mall along with your girlfriend. Assume for 1 hour you spend 100, for 2 hours you spend 500 rupees. For 3 hours that you spend what? 1,000 rupees. 4 hours, 1,500. 5 hours, 2,000. If you spend more than that, you'll go bankrupt. Your purse, your wallet will be empty. If you observe such a correlation, wherein as and how your time spent increases, as and how your time spent increases, if the amount spent also increases, then it is called as positive correlation. If one variable increases and another variable also increases alongside that, it is called as positive correlation. Direction. It will tell you whether the direction is positive or no or negative. Let me give you an example of negative correlation now. In negative correlation, I'll take example of workforce analytics. What people have done is they have tried to plot and try to look at the correlation between experience and the productivity. Okay, experience. There are a lot of leading journals which are available. Okay, experience, and on y-axis they have plotted productivity. Productivity can be measured in something called as function points when it comes to software industry. It depends on amount of time that you spend, so on and so forth. Yeah, there are various ways of measuring productivity of employees depending on what role they work in. Say with respect to experience, you have 1 year experience, 5, 10, 15, 20 years, 25 years, in that way, 30 years. And on y-axis, you have high productivity, medium productivity, low productivity, in that way. Usually what happens is whenever a fresher, okay, whenever a fresher joins a company, they work very well because they want to prove a point. Their productivity will be very, very high. I'm not saying this according to Workforce Analytics Journal. This is what they say. The moment you become a team leader after say 5 years or so, what you do is you try to assign the work to your team members. So what would happen? Your productivity would slightly decrease because you are offloading the work to someone else. Say after 10 years or so, you become a manager. What do you do as a manager? You assign the work to your team leaders. So your productivity further decreases. And after 15 years, maybe you become head of department or vice president. You are given a separate cabin, and maybe you're watching YouTube videos, Netflix movies, right? That's on a jovial note. Okay. So as and how the experience level increases, supposedly productivity decreases. Am I saying this? No, Workforce Analytics is saying. When you see such a correlation wherein as and how the experience increases, productivity decreases, if you see such a correlation, it is called as negative correlation. That's called as negative correlation. And a few years back, there was another article published on Workforce Analytics. Amazing article. Let me also explain about that. And that article was about mood of the manager. So what they have done is they have plotted the number of days in a month, 1, 2, 3, 4, 5, in that way, 15 days, 16, 17, 18, 19, 20, all the way until 30 days. They plotted that. And then they looked at, here they plotted days, and here they plotted number of times your manager shouts at you. Very interesting. Okay, so let me pull that. Sorry. Okay, on x-axis they plotted the number of days. On y-axis they plotted the number of shoutings. Then on day one, this manager shouted many times, multiple times at the team members. Then the shoutings came down significantly, you know, and no shoutings for 15 days. On 15th day, again the manager shouted multiple times. And again the shoutings came down significantly. And again on the 30th day, the number of shoutings have again gone up significantly. Now, question to you is that why do you think the manager is shouting once in every 15 days? Why is manager shouting once in every 15 days? Yep. Anyone? Let's see how many of y'all will get it right. Very interesting. Why, friends? Psychological analysis, exactly. But why? Why do you think manager was shouting? Boss also. His boss also is same. Okay. He got frustrated. Workload. Uh-huh. Interesting. Interesting answers. Very interesting. Okay. Now let me tell you. This is closely related to. This is closely related to psychology or natural phenomenon. Let me tell you that. It is very closely related to natural phenomenon. Now, can you change your answers? Natural phenomenon. Some natural phenomenon was happening because of which manager was shouting. Okay, let me tell you. What they have done is they have tried to correlate the mood of the manager with whether it was full moon day or no moon day. whether it was full moon day or no moon day. It happens once in 15 days, right? Paurnami, Amavasya is what they call it. Full moon day, no moon day. Wonderful analytics, right? On HR analytics, workforce analytics. That's a very big profession, guys, by the way. Psychology and all that. So what will you do? What action will you take then? If your manager is shouting at you once in 15 days, what action will you do? Will you take? Let me see. What action will you take? What action will you take, friends? Any guesses? Anyone? Yeah, exactly, Subrata. You got it right. You apply for leave on those days. You apply for leave, right? So you're proactively taking an action. That's just one analytics. Okay. What action they have taken, I think you can refer to HR analytics or workforce analytics magazines. You'll get to know. But that's what I felt interesting. I picked that. Okay. So scatter plot. Let me go here. Scatter plot will help you understand the direction of the correlation on whether two variables are correlated positively. Here also two variables are correlated positively. Here they are correlated negatively. Negatively. Here they are positive, here they are negative. Now, alongside positive or negative or no correlation, here there is no correlation. So let me tell you that scatter plot will help you understand on whether the correlation is positive or negative, or whether there is no correlation. The next thing that you would come to know is strength. Strength. If the data points here are closely cluttered, if they're very closely cluttered, that's called a strong correlation. If the data points are slightly scattered, it's called as moderate. If the data points are very closely cluttered, it's called as strong. If the data points are slightly scattered, it's called as moderate. If the data points are slightly scattered, it's moderate. Very close, strong. If the scatter is even more, then you say that it is a weak correlation. So the strength can be strong, moderate, or weak. Strength can be strong, moderate, or weak. Then it will also help you understand whether the correlation is linear or non-linear. So if you observe here, if you find that the data points are along a straight line, if you find that the data points fall along a straight line, like that, straight line, it is called as linear relationship. But when your data points are not falling along the straight line, for example, here, there's a curve like that. This is called as non-linear relationship or curvilinear relationship. It's non-linear or curvilinear relationship. All with me? So you will understand whether the relationship is linear or non-linear as well. Now what we shall do is, I'm going to go to R and there is a specific data set, okay, which I'm going to pull up. I can rather type. Let me open R Studio. I'm going to take a specific data set and help you understand this with respect to that. This is actually about our forecasting model. Okay, let me quickly search and try to locate waist circumference, post issue data set. Complete this thing. It should be there somewhere. Just give me a minute. Waist circumference thing slash it. It's still searching. Or let me search for data sets. It's there, we can get it. Or I have a solution for this. We have data sets here. Let me copy the required data sets. We are going to use two data sets today. Let me copy both of those to the desktop. And then we'll proceed further. So let me load a specific data set and then I'll explain about this and then we'll proceed further. Whenever you want to import any data set into the tool called R, you have to do a drop down here, click on from text read R, and then browse, locate for the file, done. I've loaded this, right? I'm importing. I'll click on import now. Pay very close attention. I'll repeat on whatever I have explained in the previous session. Here, when you import the dataset using this option, there is a library or package called readr which gets invoked, right? So you have a library or a package called readr that got invoked. Any package or library contains what? Collection of code or functions which someone else has written in the past and we are trying to reuse that. Within this readr library, you will have a function called read underscore CSV. And within the double quotes, you're giving the complete location of the file along with the name of the file and the extension of the file. And using this assignment operator, you're assigning it to an object called WC underscore 80. Okay, you're assigning it to an object called WC underscore 80. That's the object. This object has 109 columns and 109 rows, my bad. 109 rows and 2 columns. So you have 1, 2, 3, 4 in that way, 109 observations or rows, and you have 2 variables or columns. Done. Now, if I want to do a scatter plot, you just say plot x comma y. So the moment I type that, do you see that pop up? Plot what? X comma y. So say x is waist circumference. So you have to go to the data set or object. Within that, we are referring to x comma y. WC underscore 80 dollar 80. Say you have a plot. This plot. Okay, let me ask this question. Waist circumference and adipose tissue, when you plotted that, what is the direction of the correlation? Yep. What is the direction of the correlation, friends? Is it positive or is it negative? Guys, come on. We believe in explaining you real life use cases, okay? So that's why we are taking real life use case. Okay, everyone is right. Everyone is right. Amazing. Amazing, friends. Really amazing. So you're saying that the correlation between waist circumference and adipose tissue is positive. There is a positive correlation. Wonderful. Now, that is right. There is positive correlation. If I ask you on how about the strength of the correlation? Is the strength strong or moderate or weak? I'm creating a poll for you guys. Please answer that. So, what is the strength of the correlation between X and Y? So, it can be either strong or it can be moderate or it can be weak. Okay, I'm posting this particular poll. Please answer. Published. Yep. Please answer that. And here we go. What is the correlation between waist and adipose tissue by looking at this plot? Can you all please answer? Let's see how many of y'all will get it right. Wonderful. Are you guys able to see my screen? Not sure. Do you see that? A few of y'all are saying it is strong. A few of y'all are saying it is moderate. A few of y'all are saying it is weak. Which one should I believe in? Which one should I rely on? I really don't know because you're giving varied answers. 1973 6. Okay. 19% of you all are saying the correlation between these two is strong. 73% of you all are saying the correlation between X and Y is moderate. And remaining, I think, how many people? 20 and 6. Now things changed. Okay. Okay. The remaining percentage of people are saying it is weak. It is how much? 83 and 92. So 8% of them are saying it is weak. Now, whom should I actually believe in? So this is the drawback with your scatter plot. Because when it comes to scatter plot, determining the strength of the correlation is subjective in nature. Subjective. It depends on the people who are viewing that. How do I objectively evaluate the strength then? Is there any objective way of evaluating the strength? Yes. Objective way of evaluating the strength is called as correlation coefficient. It's called as correlation coefficient. So let me go back to the slides and explain that. Correlation coefficient value is represented using small r, and it ranges from -1 to +1. It ranges from -1 to +1. And if this correlation coefficient value is greater than 0.85, you say that the relationship is strong. And if this correlation coefficient value, absolute value, is less than 0.4, you say that it is weak. Friends, This is a thumb rule. When I say thumb rule, it is not crafted on stone, right? These thumb rules vary from person to person. In a few books, it says modulus of R greater than zero point 0.8 is strong. In a few other books, it says modulus of R greater than zero point 0.7 is strong. In a few books, zero point 0.9. So different books have different versions, but majority of the books say if modulus of R is greater than 0.85, that means the relationship between the variables is strong. So let's go back here. Correlation coefficient. It is always represented using small r, and the values of this range from -1 to +1. And if modulus of r is greater than 0.85, we say that it is strong correlation. If the modulus of r is less than zero point 0.4, we say that the correlation is weak. Anywhere in between these two, it is called as moderate. So let us see here on what is a correlation. To calculate the correlation coefficient value in R, you have to do COR, correlation. Again, when I say COR, it says X and Y here. I'm sure you are able to observe that X and Y, very small though. So you type X, comma, Y. There we go. What is a correlation coefficient value? 0.81. It is 0.81. Now, is this 0.81 strong or moderate or weak? It is almost close to be called as strong, but it is moderate. Why is it moderate? Because a thumb rule says that only if it is greater than 0.85 it is strong, less than zero point 0.4 is weak. So in between 0.4 and 0.85 it is moderate. Okay, so this is moderate correlation. Here, if I say R value is minus 0.87, pole coming your way. If let me put a different pole now quickly. Let me reset the pole. Let me add a new pole. Okay. R value is equal to minus 0.87. So is it negative and strong? Negative and moderate. Negative and weak. Which one is that? I'm just posting that. Done. Yep. Can you all please answer that poll? Now I understand. Okay. A lot of y'all are getting it right. Still, the majority is getting it right. But a few of y'all, I understand where you are confused. Okay, let me solve that. Good that I asked that question. Now I can clarify this doubt to you guys. So friends, positive need not always mean strong. Okay, positive can be strong or positive can be moderate. But negative, when you see here negative, negative can also be strong. It can also be strong negative correlation, or it can be moderate negative correlation. Negative does not mean it is weak. Negative just means the direction. That means as in how your age increases, your metabolism rate decreases. That's fine. That's how it is, right? So it's negative. But if the data points are closely cluttered, it is strong. So negative can also be strong. So this minus 0.87, one is negative, that is taken. It's negative correlation. But what did we write in the formula? Modulus of R. So if I take modulus of R, that means if I take modulus of this minus 0.87, for negative values, if you take modulus, you get a positive number. And this 0.87 is greater than 0.85, hence it is strong. Hence it is strong. And if you look at this, relationship is positive because it's a positive sign. Strength is moderate because it is neither greater than 0.85, this value, nor is it less than 0.4, it falls in between. So it's moderate. This is how you determine the strength of the correlation. So we understood about scatter plot. We understood about the strength. We know that scatter plot strength is subjective. Hence, we are resorting to objective way of evaluating the strength using correlation coefficient. So I repeat once again, whenever you join your organizations, any company that you join, when you start working on projects, they will let you know on what is a business problem. Based on that, you need to collect the data, and you know about the various data types. And once this is done, you proceed with exploratory data analysis. First moment, second moment, you try to describe your data and draw as many meaningful insights as possible. And then you do a univariate plot, that is bar plot, histogram, and box plot. You also do scatter plot. Okay, you also do a scatter plot when you have two variables. Scatter plot will help you identify the direction, positive or negative or no correlation, strength, whether it is strong, moderate, or weak. And then since the strength is subjective, objectively you'll evaluate using correlation coefficient. Once you draw all these insights, the next step is building your machine learning algorithm, that is data mining. Within data mining, there are two branches: supervised learning and unsupervised learning. Supervised learning, unsupervised learning, these are called as machine learning. Okay, machine learning or building your prediction models, predictive modeling. So we will, you know, walk through all these steps using a real life business problem. See, I can as such take inbuilt data sets in R, but that way you'll not learn the real world business problems. You'll become theoretical textbook data scientist. No, the objective is in these 20 hours, whatever you learn it to the perfection. That's the objective, right? And we are going to learn post our break about an algorithm called as linear regression. Okay? And there is also another algorithm, friends, that we will learn, which is logistic regression. So the thin line of difference between these two predictive models is that if the output that you're trying to predict is continuous, then you proceed with linear regression. If the output that you want to predict is discrete, and if you have two categories, I'll get to this, I'll in detail explain everything. If your output variable is continuous, you go with linear regression. If your output variable is discrete in two categories, you proceed with logistic regression. Not just that, not just that. We will also learn about something called as unsupervised learning, and we'll just touch upon one algorithm. We will look into association rules, right? And finally, I also wish to explain you about something called as text mining as part of unsupervised learning. Slowly and steadily, depending on the amount of time that we have, we will look into what else we can study. So it's 2:58 now. It's 2:58. Let us take a quick 10 minutes break and come back by 3:10. Break time. Okay. Please come back by 3:10. Session will start at 3:10. Okay. Please take a break, friends, and let us all meet again on the other side of the break. Hey, hello everyone. Are you all back? Wonderful. Okay. So friends, we thought that from tomorrow onwards, we will give away two awards, not one. One will be for people who stay until the end. Another will be for a quiz. It will also help you learn. Okay. There will also be a quiz on LinkedIn. So that is what we thought. So Enoch, oh, you are all already there. Okay. Enoch, would you like to post that, friend? Okay, so let me click on that. Here we go. That's the link. This is the question and answer. So complete the following steps and win a surprise gift. Tomorrow we will look at the surprise gift. Okay. And you'll have to take this. How do you take that? You will have to just follow us. And then how do you follow us? Please go to 360digitmg.com. Please everyone go to 360digitmg.com. And when you go to 360digitmg.com, you'll have to scroll down completely and not the YouTube link. Now click on LinkedIn. Click on the LinkedIn link. The moment you click on that, it opens the LinkedIn profile, our page. Click on follow. Okay, you just click on follow. Okay, and the moment you click on follow, you would be following us. Once you follow, you'll be able to see the posts, right? You'll be able to see all of our posts, and you refer to this post. You'll refer to this post and answer these questions. Comment yes in the comment section once you're done. Follow us on LinkedIn page, and your answers don't post it here because other people might copy. Remember, you will win if you get it right. I mean, not everyone. Again, we'll do a surprise. Randomly, we will choose one person on this WhatsApp number along with your email ID. Along with your email ID. Enoch, we might want to change this because two people might have same name. Along with your email ID, right? You please send the answers. We will pick the winners in tomorrow's session. So I repeat, go to 360digitmg.com, scroll down completely and click on LinkedIn. When you click on LinkedIn here, it will open a page like that. You'll have to click on follow and then you will find our post. Please say yes the moment you complete the quiz. And on WhatsApp, I request you all to send your answers along with your email ID on this number, which you're seeing here. And tomorrow, we are going to pick up the winners. All with me? Game for this? Let's see. Are you all game, friends? Can you all please respond? Yep. So do that. Answer. It's a simple thing, but it will help you learn. Now back to our discussion. Since you're back from break, quick recap. Each time you need to understand the business problem, you need to collect the data, explore the data, and perform whatever is the objective. Your objective is to build a prediction model. Do that. So I will go back to the slides and I will take you guys to this slide, which is important. Okay, read this and let me know on what is the business problem that people are facing. Okay, please read, take out 2 minutes time, read it, understand the business problem. We want to give you real world experience, friends. Please don't ask for inbuilt R files or data sets. It's not going to help you learn anything apart from programming. Okay, please do this. We heard you. You wanted the data sets from our side. We heard you. We will let you know how and when we are going to give you the data sets. Right? We will give it to you tomorrow. But how we shall distribute the data sets, we would decide upon that. Okay, let's together read it. Studies have shown that individuals with excess adipose tissue means if you consume excess fat that gets deposited underneath your skin as fat, that's adipose tissue. Okay, and studies have shown that individuals with excess adipose tissue in the abdominal region, that's around your fat tummy, have a high risk of cardiovascular diseases. Okay, they have a higher risk of cardiovascular diseases. Then people use CT scan, which is called as computed tomography, to measure adipose tissue or the fat in your body. But there are problems associated with CT scan. What are those problems? Many doctors, physicians do not have access to the technology. Second, it suppresses the immune system, right? When you do a CT scan or when you undergo a CT scan, it will suppress your immune system. And it is also expensive. It is also expensive. So many physicians do not have access. It will suppress your immune system and it is expensive. So group of hospitals have come to you because you are now data scientists. You all are data scientists. So say group of hospitals come to you and say that, do you know what? Can you help me predict the adipose tissue without the patients having to go through CT scan? Can you do that? Something which is easily available, something which is risk free, and something which is inexpensive. Can you help us with this? Then you all data scientists, now I'm calling you all as group of researchers, right? Group of participants who are attending this training, say you conducted a study, you have done some market research, and your aim was to predict the adipose tissue. And then you thought that we can predict adipose tissue by measuring the waist circumference. By measuring the waist circumference, we can predict the adipose tissue area. You concluded that. That is a business problem. Once you understand the business problem, what is the next step, friends? What is the next step? Do the data collection. Collect the data, right? And you go back to the hospital and say, hey, hospital, I understand, but can you give me the data? Then hospital will ask you, what data do you want? What data do you want? Then you'll say, do you know what? I want to predict adipose tissue based on waist circumference. So I need waist circumference and adipose tissue of the patients. Okay, hospital goes back and looks at the data that they have and they say that, do you know what? We have data of 109 patients. We have data of patient 1, 2, 3, 4, all of these people until 109 patients. Perfect. And what do you have? You have waist circumference and adipose tissue. You have what? Waist circumference and adipose tissue. So the output that you want to predict is adipose tissue. Okay, let me erase this. The output that you want to predict is adipose tissue, and the input which is provided to you is waist circumference. In the past, This data is called as what data? Historical data, past data. Okay, this data that you received is historical data or past data. You have adipose tissue and you have waist circumference. Waist circumference was measured using a measuring tape. You have a tape to measure, you take that, and then the hospital people have measured the waist circumference of patient. For CT scan, they have passed this patient through CT scan and measured this adipose tissue. In this way they measured. How did they measure waist in the past? Using measuring tape, and adipose tissue was measured using CT scan. So you have the historical data. Given this historical data, what is the next step? You need to perform exploratory data analysis. That means you have to calculate mean, median, mode, then standard deviation, variance, range. Then you have to do graphical representation. Histogram, box plot, scatter plot, all of these things have to be done. So we will not do all of those because already we calculated mean, median, mode and all that, but a few things we will learn. So in order to quickly explore the data, there is a function called as summary of WC underscore AT. Summary of this. In this data set, WC underscore AT, you have waist circumference and adipose tissue. So for both of these, when you say summary, it will automatically calculate the minimum value, maximum value, mean, median, first quartile, and third quartile. Minimum, maximum, mean, median, first quartile, third quartile. All these you would instantly get the moment you run summary of the name of the data set. Once this is done, that is once you're done with the exploratory data analysis, you proceed with scatter plot. And we have done the scatter plot. Already we have done this. We also know the correlation. Now question to you, or let me rerun that. So if you say plot of x comma y, you get the scatter plot. You all told me collectively that as and how the waist circumference increases, adipose tissue increases. So this is a positive correlation. Wonderful. The first thing that you come to know about the direction, which is positive. Second, strength. To evaluate strength, we looked at correlation coefficient value. Or let me rerun that again. When I press up key on my keyboard, I go to the previous function. We discussed this already. There we go. So the strength by looking at this number is moderate. Why is it moderate? Because it's in between 0.4 and 0.85. Okay, we got this. So the strength is moderate. Strength is moderate. Third, is the relationship linear or non-linear? Okay, let me go for a poll now. Look at this plot. My question here is the relationship linear or non-linear? There's a poll coming your way. Answer that poll, please. Reset. Next poll. Is the relationship between x and y, or I would say, what is the relationship between x and y? Is it linear or is it non-linear is my question. So I preview that and publish. Yep, please answer that, friends. There is a poll live. Is the relationship between waist circumference and adipose tissue linear or non-linear? Wonderful. Wonderful, guys. So it is linear. Majority of y'all are saying it's linear. Yes, it's linear. Linear means if the relationship is falling along the straight line, it's linear. If it's like this, if all the data points are like this, then it is non-linear. Yeah. However, any shape which is not straight line, it could be like this, it could be like this. Any shape other than straight is linear. Perfect. So you know that relationship is linear in nature. Wonderful. We understood about all of these. Linear means a straight line. Okay, now please pay attention. We are moving to the most important step of data science, of building the prediction model. Pay very close attention. So you understood the problem, you collected the data, you have done some research on the data. Now you're trying to build a prediction model. If I go to this data, what is this output variable? Is this continuous or discrete? People, is this continuous or discrete? Is adipose tissue continuous or discrete? Let me quickly put a poll for this as well. A new poll. Okay. Is 80, what type of data is adipose tissue? Is it continuous or is it discrete? There we go. Done. I published. Can you please answer? What type of data is adipose tissue? Any data which can be represented in decimal format. And if it makes sense, it is continuous data. Wonderful. You all got it right. I mean, you guys have a very good analytical mindset. Trust me on that. Majority of y'all are getting it right. And that is what is needed for someone to become a successful data scientist. Right? Good. I appreciate that. So output variable is continuous. When your output variable is continuous, you proceed with what technique? Linear regression. You proceed with a technique called as linear regression. So that is what we will do now. Since it's linear regression. And also output is continuous. So you have to do linear regression. If you look at this data, if you look at this plot, let me choose a different color. Okay. Let's go to this first row, waste. What is waste? 74.75. Where will that be? Waste 74.75, somewhere in between here. Then what is adipose tissue? 25.72, 20, somewhere here. If you go along this direction and this direction, I think this is the point. Okay, that's the point. This one, black one. First point. Then let's go to some other point. Let me go to this 83.95. 83 might be somewhere here, and 42.8 will be somewhere here. So if you were to just plot that, maybe this or this, one of these points is this point. In that way, how many points do we have here? 109 points. These points that you're seeing here, these circles, these points that you're seeing here, all these points are called as your actual data. These are all your actual data, which, I mean, you already have the data. Actual data, you already have it. What we need to do now is, given this data of adipose tissue and waist circumference, output and input, Y is output, X is input. Given this data, we need to build a prediction model, which should be used for future prediction. Please pay attention. If you don't understand this, that means you did not understand anything. Okay, please understand, please focus. Using this historical data or the actual data which is already given to you, we need to build a prediction model which will predict adipose tissue based on waist circumference. And any machine learning algorithm on the planet does only one thing. What is that one thing? It will try to establish the patterns. It will try to establish the patterns or mathematical relationship. Mathematical relationship between y and x. All any machine learning algorithm on the planet would do is it will establish the mathematical relationship and the patterns between y and x. Since these data points are falling along the straight line linear, right? We want to capture the relationship between y and x, between adipose tissue and waist, using a straight line. So all these points are actual points, and this line is called as prediction line or fitted line. Prediction line or fitted line. Question to you all. All these points, all 10 points. Actually, you have 109 points. Right? And since the relationship is linear, you thought that using a line, I can establish the relationship between adipose tissue and waist. Question to you all, what is the equation of line? Friends, what is the equation of line? You all would have learned this as part of your school days. Equation of line. Exactly. Equation of line is y is equal to b plus mx or mx plus b or mx plus c, however you want to write. Right? Y is equal to mx plus b or mx plus c or b plus mx, however you want to write it. This b is called as intercept. And this m is called as what? Friends, what is m called as? Slope. When did you last learn this? We have last learnt about this equation of line when we were in our school days. 8th standard math is what we are learning. Is 8th standard math so difficult? No. Back then we have learnt it probably just to pass the exam. Now we are learning it to get good salaries. Data scientist salaries are skyrocketing. Okay, I'm not sure. Okay, let me just go a little off board. Let me take a slight detour here and then show you the salaries that data scientists typically get. Salaries of data scientists in India. Okay. All these. You can just watch. You can just watch. Average salary is 8,27,000. And there are a lot of news channels, friends. Let me go here. Let me go to Times of India. Some eligible thing I need to go, right? What does economic time says? Data scientists earn a salary that's 2 to 3 times higher than IT programmer. I'm not saying this. Economic Times is saying. This is a fact. This is the fact. Okay. Data scientists are earning more than chartered accountants and engineers. India likely to see 62% rise in data science job openings in 2020. 62%. What else do you want? What else are you looking out for? So look at this. Economic Times is another thing. Close to 97,000 positions related to this analytics and data were vacant. Why were they vacant? Tell me. Because of lack of talent. Simple. Because of a dearth of qualified talent. People are learning, but I mean, with all due respect, someone was saying, can you use examples in R? See, friends, when I use examples in R, you will not learn about real world problems. You'll not understand real world problems. First. Second, a lot of people are getting trained. And if all these people who are getting trained go and attend interview, then whom should the interviewer hire? Someone who has practical experience. And as I was saying, right, in our 250, let me go there, digitmg.com in courses. This is the first course, data science course training. And here you'll observe that we have 250 plus hours, 140, 140. And in this, we are going to teach all these techniques, all these things. And the one thing that is not mentioned here is that we give 100% job placement, 100% for people who undergo everything. It's roughly 6 months. And we give 40 hours of core training just to clear the interviews. Just to clear the interviews, we do that. Okay, that was a side detour, but yep, makes sense, right? So please, this is 8th standard, 9th standard math. Nothing difficult about this. So high salaries, so many job opportunities. So you should be better positioned. Learn, right? Learn. Don't have too many doubts. In learning, you should not have too many doubts. Okay, now this is what is the equation of line. Now that we are grown up, now that we are learning for getting a good job, getting good salary, the equation of line slightly changes. Y is equal to same thing. Instead of b, I'll make it beta naught plus instead of m, I will denote as beta 1 into x. That's it. Same equation of line is this. Now, question to you all. Is this equation of line that I've drawn, is this equation of line that I've drawn, is the best line? Or let me draw in blue color. Is this the line which will capture the relationship between x and y correctly? Blue line. Or is it the pink line which will capture the relationship between x and y correctly, right? Or is it the red line? This is a question. Let me open a poll. Let me open a poll and take a poll. Here we go. I'm asking a poll question. Reset and the question. Okay. Which line is the best fit line? Red color line or blue color line? Or is it pink color line? Yep, I published. Please respond. I will expand this. Please respond to that question. Is red going to capture the relationship between x and y correctly? Or will blue line capture the relationship between x and y correctly? Or is it pink color line which will capture the relationship between x and y correctly? Let's see which line captures the relationship correctly. Majority of them, majority, absolutely. I mean, once again, you guys have very good analytical skills. No doubt about that, right? Yep. Majority of you all are saying red color. Exactly, friends. Exactly. Red line. Why? Because this red line is closer to the actual points and you want your predicted values to be closer to your actual points. Wonderful. You got it right. This is the equation of line. Okay. Then So what you have to do is to decide upon which line is the best line, what we usually do is we calculate the distance between actual point to the predicted line, actual value and the predicted value. Find the distance between actual and predicted. The distance between actual and predicted, this is actual point, and this point would be on the line which is predicted value. The difference between predicted value and actual value is called as error or residual. Error or residual. There's thin line of difference between error and residual, predicted values and fitted values. That's part of our main program. But now let's understand this. So you get one error here, error one for the first point. Then you find the distance between actual value and predicted value. That will give you error. So second error. Find the distance between each point, each actual value to the predicted value, actual value to the predicted value, actual value to the predicted value. Find all these distances. Okay, when you find all these values, you'll get how many errors? We have 109 points in total. So you'll get error 1, error 2 in that way, 109 errors. 109 errors. I mean, for all the points, you'll have errors. You square all these errors. You square all these errors. So you have all the errors. You square all these errors and add them up. Sum it. So you sum all these squared errors. You sum all the squared errors, which is called as sum of squared errors. Hence, the technique used to find the best line, best fitted line, is called as, this technique used to find these is called as OLS, or it is called as ordinary least square technique. OLS technique or ordinary least square technique. Simple. Since the relationship is linear, I believe straight line will capture the relationship between y and x. I got the best line. How did I get the best line? By drawing a line and finding the distance between actual value and the predicted value, which is nothing but error. Since I have 109 points, you get 109 errors. You square those errors and add them up, which is sum of squared errors. And this overall technique is called as ordinary least square technique. Simple. Now what we shall do is we will run a model, linear model of y tilde x. So I'll do one thing, I'll attach the data set. When you attach this data set wc underscore 80, what happens is you can directly refer to these columns, and the equation is y is equal to, sorry, equation on R, the way you write is linear model of y tilde x. Linear model of y tilde x. Y is your adipose tissue, x is your waist. So that's, it's very simple. Linear model of y is adipose tissue tilde waist. When I run it, you get an equation. And what is the equation of line? We already discussed. Y is equal to beta naught plus beta 1 into x. So adipose tissue is equal to, what is beta naught? Its intercept value, which is minus 215.981, plus you have the beta 1 value, which is 3.459 into x. What is x here? Waist circumference. X is waist circumference. That's it, done. You have built a prediction equation. We have a prediction model. You give a pat on your back, friends. We just built the first prediction model using 109 data points. Okay, you have 109 data points if you observe. Now, if 110th patient walks into the hospital, I will take a measuring tape. I'll measure the waist circumference. Say waist circumference is 100. I'll take this value 100 and substitute in this equation. Then what will I get as adipose tissue? Adipose tissue is equal to minus 215. I'm typing it, minus 381 plus 3.459 into what is the waist circumference? You're saying it's 100. Oh, sorry, my bad, my bad. Just taking it like that. Into 100. That's it. How much did you get? 129. So you go back and report to your hospital that, do you know what? Don't ask this patient to go through CT scan. Why? Because I built a prediction model and the adipose tissue is 129.9. Done. So hospital need not have CT scan. And the problems that we had in the past, did we solve those? Yes. What was the problems? Physicians do not have access to CT scan. So what? You solved it. You have an equation now. You need not expose your patients to CT scan. So it is not going to suppress your immune system. And this equation is not expensive. I can just go give this equation to any doctor. They will put it in a calculator or Excel and job done. So it's easily available, risk-free and inexpensive. Go collect your consulting fee from the hospital and job done. Okay. But in our full-blown program or our full-length program, we get into a lot of depth than what I've explained. I've just explained the scratch of the surface, but this is good enough for you to at least start exploring further. Okay, now let me do a recap on what I've missed out. So we have built an equation which is y is equal to beta naught plus beta 1 into x. Simple. This equation can be used for future prediction. Simple. Job done. Now you had a single input, right? You had output variable which was continuous. Agree. And you had only waist circumference as input. So you had a single input. When you have a single output and a single, sorry, when you have an output which is continuous and when you have a single input, it is called as simple linear regression. Okay, when you have an output variable which is continuous, and if you have an input variable, wherein if you have multiple input variables, then you proceed with multiple linear regression. So what did we just do? Say you join some company, Infosys, you join a project, you want to do a project. They will tell you the business problem like this. Then what did you do? You went ahead and collected the data of 109 patients. That's the second step. Then what did you do? You have done exploratory data analysis. Then what did you do? You have built your linear regression, simple linear regression, and you have given that equation, this particular equation, to your customer. That's it. Job done. How do you deploy it in production, etc., etc.? That's part of our main program, but this is how you build your model. Okay, so for tomorrow, what are we going to do? Okay, tomorrow we are going to discuss about multiple linear regression on a data set wherein you're going to predict mileage of a vehicle even before a vehicle is manufactured. even before a vehicle is manufactured, can I know how much will be the mileage that vehicle might give? And you'll have various inputs, such as how powerful is the vehicle, horsepower, how heavy is the vehicle, weight of the vehicle, and what is the volume of the vehicle, right? And then what is the speed of the vehicle? Given all these, we will predict mileage. India is mileage sensitive country because petrol cost is higher. So for us, upfront, even before we manufacture vehicles, we need to know how much mileage it will give, given the horsepower, weight, volume, and top speed. We also have to meet the regulatory conditions that your vehicle should not be less than so much weight, etc. There'll be certain conditions. After that, we will also learn about logistic regression, two categories. Let me give you examples. Will an employee resign or not? Upfront, you can predict on whether a person will treat or not. A person who has applied for a loan, will that person default or not? Can I upfront determine, even before I lend a loan, can I decide on whether a person will default on the loan or not? Yes. If you swipe a credit card or a debit card, is it fraud or not? Can I upfront determine that? Yes, you can upfront decide that. Okay, you can upfront decide that. Then there are a lot of things, like if you have an insurance policy, would you claim that insurance or not? Tomorrow, the use case that we are going to learn is slightly related to insurance industry. And these are all the real world experiences, friends, real world use cases. Once again, I repeat, become a practical data scientist and not a theoretical data scientist. If you become a theoretical data scientist, you might not get a job, right? That is the reason why I've shown you on internet clearly that though there are a lot of job opportunities, 97,000 positions are not filled because of theoretical data scientists, those who are just getting trained and then going and attending interviews. Why would anyone hire you guys? If you don't have practical experience, no one will hire you. Okay, remember that. And let me take your questions. And a few of you all were also asking me on, hey, can we have your LinkedIn profile? Already, friends, I posted that. Already, I posted my link, LinkedIn profile, but let me again post it for you all. Connect with me. Okay. And where do I put that in chat? There is a, oh, okay. Even before that, okay, I posted it here in the chat. Please give your attendance. It is mandatory for you to receive a certificate at the end. Our certificates carry some value. There was someone who was asking that question on, hey, what value does this certificate have? It will have its own value. During the lockdown, you are upskilling yourself. You are sending clear message to the potential interviewers saying that you are upskilling yourself. See, Kyati, Parasi, Kyati, we have a moderator team who is watching all your chat messages and responding. What happens is 1,000 people responding. If I keep addressing the questions, tell me frankly, will I be able to conduct the session? No, right? Hence, we are doing this. Okay, a few questions might get unaddressed, but again, we will discuss. No worries. We'll look at your questions and then we will address that. Yeah, I'm with you guys. So there is an attendance tracker. Okay, please look into that. And if someone wants to connect with me on LinkedIn, I again sent my LinkedIn profile. Please connect with me. Okay, all right then. And the this part, what the competition part, please go to 360 digitmg website, 360digitmg.com, digitmg.com. digital transformation, management and governance, and click on LinkedIn here at the bottom. And the moment you do that, you will have to click on follow here. You'll have to click on follow. Once you do that, all you need to do is scroll down and you will see this. Okay, you will have to click on yes in the comment section. You will have to follow us on LinkedIn, of course, and then WhatsApp the answers to this WhatsApp number along with your name and email ID, so that tomorrow we might pick one of you all as a winner. And sit back and relax, enjoy your studies, watch the recorded videos again, and come back prepared. Thank you all so much. We will connect again tomorrow and take this discussion further. Thank you all. You all are analytical, just ensure that you do well.